So this is a revision of fifth year work, and it should be very straightforward for you. What we want to do is to sketch the polynomial given and identify x and y intercepts and the turning points and their nature. So first thing then, the x-intercepts. Now the x-intercepts always occur when y equals 0. The function is given in factorised form. If that were expanded, it would be a cubic function, which we would then have to factorise. So things are just a bit easier for us. X minus 1, x minus 4 all squared equals 0. And we should know then that x minus 1 equals 0 and x minus 4 equals 0. X equals 1 and x equals 4. So we have x-intercepts at 1, 0 and 4, 0. Next thing to do to work out the y-intercept. The y-intercept always occurs when x equals 0. Now what we don't have to do is, we don't have to expand at the moment. We will have to expand for the next step. So I can replace x with 0 here and x with 0 here. That gives me y equals minus 1 from the first bracket and minus 4 squared. So that's minus 1 times 16 minus 16. So we have a y-intercept then at 0 minus 16. Now, I said just a moment ago that we would need to expand the brackets at one point. I was thinking about differentiating to find the stationary points, but in fact, why don't we just apply the product rule? So we can make this term 1 and this could be term 2. So dy by dx then, differentiate the first, that would just give us 1, leave the second, and leave the first, differentiate the second. That gives us 2 x minus 4 to the power of 1. What I'm going to do here is to take out x minus 4 as a common factor. That will simplify things, so x minus 4, and that will leave me with an x minus 4 from the first term and 2 lots of x minus 1. Now, so that's 2x plus 1x is 3x. And what have we got then? We've got minus 2 minus 4, that's a minus 6. Now that's handy, having it in factorised form. So dy by dx equals 0 for the stationary points, and we'll have x minus 4 equals 0 and 3x minus 6 equals 0, x equals 4 and x equals 2. So there are 2 stationary points. What we need to do now is to work out the y values, and I'm going to use the factorised form to work out the corresponding values of y. So y of 4 is 4 minus 1, which is 3. 4 minus 4 is 0, so that's going to be 0. That means we have a stationary point at 4 along 0 up. Y of 2, so that's 2 take away 1, which is 1. 2 take away 4 is minus 2. That minus 2 is squared, that gives us 4. So we have a second stationary point at 2, 4. That's x minus 4, 3x minus. So next thing to do is to discover the nature of the stationary points. X dy by dx, now that equals 6, and then we have the shape. So we have stationary points at 2, and at 4. We know that this will be 0 here, and this will be 0 here. Now, let me just take the value 1 and 3. So I'm going to substitute x equals 1 into these brackets here. So that gives me a minus 3 times another minus 3, which is positive. If we take the value 3 then, so that's negative. 3 times 3 take away 4 is minus 1, but that's positive. Negative times positive is negative. Let me just take 3 and 5. Oh no, that's going to be negative. 5, so that's positive, and that's positive. So what do we have then? We've got a maximum TP at 2, 0, and we've got a minimum turning point that's 4, 0, and this is not correct, this should be a 4. So the last thing that we have to do is to sketch all this information. So we've got turning points at 4, 0 and 2, 4. We have a maximum at 2, 4 and a minimum at 4, 0. We know also that there is an x-intercept at 1 and 4, which is already marked here, and we have a y-intercept at minus 16. So this all fits together quite well. And that is the graph of our function.